Hello, environmental scientists. In this PowerPoint presentation, I'm going to teach you how to make a dose-response graph. In class, we would actually collect our own data, but I'm going to give you some data to do this. This is what your assignment is going to be. In the last presentation, I talked about toxicity testing, how when we test for toxins, we do it in such a way that we're seeing at what concentration we are going to have a 50% survival rate, and we do it one chemical at a time. So we're going to find out what the 50% survival rate is for acetic acid. We're going to look at the LC50, the lethal concentration of 50% of a population of brine shrimp. And we're going to do this by adding it to the environment of the brine shrimp. That's why it's a lethal concentration, because we're going to make a concentration of water and vinegar, and then we're going to put brine shrimp in it. Because this is volumetric, we're going to measure it in volume, and the pretty standard one is ppm, parts per million. First up, we need to make a concentration gradient. So how do you do that? You start off by buying 5% acetic acid. That's where we're going to start. So I'm going to put in a test tube 5% acetic acid. That's my table vinegar. I'm going to assume that that's going to probably kill off most of my brine shrimp. So I want to dilute it. So I'm going to make a concentration gradient where each test tube is 10% more dilute. So 10% less strong, 10% more dilute is 0.5, right? I'm just moving my decimal. So next we have 0.05, and then 0.005, and then 0.005, and then 0.00005%. So at this point, it's barely vinegar anymore. We'll probably have 100% survival. What that looks like is we put 6 test tubes. The first one is 10 milliliters of 5% acetic acid, and the last one will be 10 milliliters of that 0.00005% acetic acid. We're going to start by putting 11 milliliters of our 5% acetic acid solution in our first test tube. And then we're going to put 10 milliliters of water in the next ones. And we're only going to put 9 milliliters of water in the last one. That's going to change our percentages a little bit, but not enough to matter for this particular experiment. Then we're going to use a straw or a pipette, and we're going to stick that into our first test tube with our vinegar in it, and we're going to take 1 milliliter of that vinegar, and we're going to put it into test tube 2. So you're going to see how this test tube is going to get lower, and this one's going to get higher. So we've taken 1 milliliter out, and we're adding it to this one. We are then going to stir this test tube. We do that by rolling the test tube, not by shaking it. And then we're going to take 1 milliliter. We've just created a 0.5% acetic acid test tube. So we're going to dilute that one 10%. So we're going to take 1 milliliter of that one and put it in the next one. We're going to stir that one, mix that one, and take 1 milliliter of that one and put it in the next one. And in this case, we're diluting by 10% each time until we end up with our 0.0005% acetic acid at the end. So if we start with 5%, if we dilute by 10, we get 0.5, and then 0.05, 0.005, 0.0005, and then 4 zeros. That is our concentration gradient. Then we want to put that into a table. So we've got our concentration of acetic acid. When we do this in a lab, we don't typically look at concentration, we look at parts per million, because that's basically milliliters per liter. So that brings those numbers up. 5% becomes 50 parts per million, 0.5% becomes 5 parts per million. This is what it looks like in a table. So now we've got our acetic acid concentrations, we've got our parts per million. Now we need to know what is our surviving brine shrimp. Brine shrimp are small aquatic critters that live in saltwater environments. You've probably heard of them as sea monkeys. You used to be able to buy these guys from comic books as sea monkeys. They have these cyst-like eggs that are quite easy to hatch if you have some salt water at your house. What I do is I usually hatch a bunch of them, and when they're in their larva stage like these guys, we do this experiment. And then once they get a little bit older, I can feed them to our saltwater aquarium at school. And hence, I'm not just wasting a bunch of brine shrimp. They feed all of the critters in the saltwater aquarium. What we're going to do is we're going to take our 6 test tubes and we're going to put 10 brine shrimp in each one. So using a pipette, we pick up 10 brine shrimp, we put them into all these little test tubes, and then we give them 30 minutes. And they're in, so the brine shrimp in this test tube are in 5% vinegar. That's table vinegar. The ones in this one are in salt water with only a little bit of vinegar. So they're taking half an hour breathing in that vinegar water, and afterwards we'll record what percentage survival rate we have. So afterwards, this is what we found. We found in test tube 1, that was our 50 parts per million vinegar, 5% table vinegar. We've had 1 surviving brine shrimp. And then we had 2 in our next one, 5, 6, 6, and then our last test tube, all 10 of our brine shrimp survived. So because we did 10, our percent survival is pretty easy to calculate. 10 is 100% survival, 6 is 60, 1 is 10%. So we can plot those points on this graph. If this is our percent survival over time, we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are horrible markers, but you get what I mean here. Our first test tube is actually over here. This is test tube 1, because you always start your concentrations at 0. So test tube 6 is our first one on this list. And test tube 6 had all 10 brine shrimp, so its point is up here. And then test tube 5 had 60%, so did test tube 4. Test tube 3 had 5%, test tube 2 had 20, and then 1. So we've plotted our points onto this chart. The next thing we need to do is to make a line of best fit. This is the hard part, and I might make another film just showing you how to do this. You need to draw a line with a ruler that shows the trend of these dots. It does not have to go through any of them. I typically try, and if I can make it go through some of them, I will, but you want half of the dots above the line and half below. Here's the line of best fit that I drew on with this computer. And I have these 3 dots above and these 3 dots below. Now I want to know at what point was 50% survival rate. Now on my chart, I have 50% survival rate at test tube 3. But that's just one example. I want to know generally what is the trend. So what I'm going to do is I'm going to find the 50% survival rate and follow that across. And then I'm going to follow it down to find out at what concentration. So what concentration is my LC50? It's right there. That's my LC50 because LC, C stands for concentration. So my LC50, I'm going to write it up here, is greater than 0.05 and less than 0.5. That is the concentration that my LC50 is at. And that is what you're going to have to write on your dose response graph. You can do this out in words. You can say LC50 is greater than 0.05 and less than 0.5 in words if you have trouble with these symbols. But the idea here is it's not a single number, it's a range. We know that the LC50 is somewhere in this range. And then next time we'll make a new concentration gradient that starts at 0.5 and ends at 0.05, and we'll get a more precise number. This is just step 1. Your assignment, I'm going to post some numbers and you are going to make your own dose response graphs. So good luck.